In this lecture, I'm going to teach you about the Coulomb's law. Now, the Coulomb law is also the part of class 11's as well as class 10's book. First of all, before starting, we should know that the Coulomb's law is related to the charges Q1 and Q2. Now, here the charges should be in rest, while we had given the value of d as d square. Now these are two factors. First the charges, second the distance. Now this Coulomb law was given by Charles Augustin G. Coulomb. This is the name of the French scientist who just gives us the Coulomb's law. He talked about the Coulomb's law with respect to the situation in which it is in rest. Like Coulomb law is only applicable when two charges are in rest. Otherwise, Coulomb's law is not applicable. Now, the Coulomb states that electrostatic force. Now, we know that when two charges are in rest, the force between them is called electrostatic force. Now, here word static means rest. Electrostatic force between two charges, charge 1, charge 2. So, between two charges are directly proportional to the magnitude of the charges. Now magnitude is the number or number of distance, number of displacement, that depends on the situation. Magnitude means the number of charges inversely proportional to distance between them. Now just suppose the force or we can say that the electrostatic force is directly proportional to Q1. If there is Q1 is equal to 2, so we will say that force is directly proportional to 2. If the force increases, it will become 3, 4, 5, 6, 7. That depends on the situation. As well as Q2. So here he states that force is directly proportional to these two charges and inversely proportional to the distance, because we know that if the distance is more, the force between them would be less. So mathematically he represents it as the force F is equal to K. Now here K is the constant equal to K Q1. And now here Q1 is the number or the unit given to the charge 1 and charge 2 divided by or inversely proportional to the square of the distance. Now here when we remove the proportionality signs, we know that the constant is given. So here I had directly written the constant. After that, the K constant also has a constant value till now. Now, if there is a constant value that we know that will never change, so we just write it in the capital form like gravitational constant. Now we know that gravitational constant will never change. So we had just given it a proper symbol. While we don't know that whether the charges between the force between charges can be changed or not. Till now, the value of this constant is 910 raised to power 9 Newton meter square divided by c square. Now here we know that Newton is the unit of the charge. So the charge Newton is equal to, now we know that we are finding the value of the K. So we're gonna just take the constant here and force there. Now let me just write the value first. This is something that we'll get. Just focus on this. K is equal to FD. Now we know that D is multiplying here when it dividing here, and when it go there it will multiply. So as it is written that F multiplied by D square divided by Q1 Q2. Now here we know that there is a square of the Q. So we're gonna just take the square of that Q because of two values. Newton is for just unit of force, meter is for distance, and this is how we get the unit of the Coulomb's law. Now, probably normally there is some problems that is given to related Coulomb's law. Now let me just give you a general problem, and by that you will be able to just solve what I have teach you. Just suppose there are two charges Q1 and Q2. The Q1's value is 3C and Q2 is 6C. 6C means coulomb. Now we know that the value of or the unit of the charge is coulomb, as I told you in previous lectures. Now here the distance between two charges is 3 meter. Now how can we solve that? Just simply put the formula. Now here the value of the K is constant. It is K constant. Q1 is equal to 3, Q2 is equal to 6. Now we know that 9, 10 raised to power 9. Now when 3 is multiplied by 6, so the answer is 18. 3 into 6, 18. Now here we use always distance that is squared. So here the square of the 3 is 9. So here this 9 would be cancelled with this 9, and the answer that would be gained is 18 10 raised to power 9. Now this is how we can solve the problem of the Coulomb's law very easily and fluently. Now this is all about today's lecture, and thank you so much for watching this video.